Have you ever wondered why, when you are working with various crops, you see this tremendous spike in plant disease right as plants are going into the fruit fill stage? If you think about tomato production, for example, we'll have tomato plants that are growing well, things are clicking right along until we get to the first cluster is sizing up several inches in diameter. The second cluster is starting to fill very nicely. And then all of a sudden, we begin having problems with early blight, with septoria leaf spot, with bacterial speck and bacterial spot and bacterial canker. All of these various diseases tend to stay kind of dormant. They don't really become a problem until all of a sudden, when we get to the fruit fill stage, we have this flush of disease pressure. And the same also holds true for many of the soil-borne pathogens. When we have challenges with Pythium or Rhizoctonia or Fusarium and so forth, these diseases can also become a problem earlier in a plant's life, and that certainly can happen depending on the soil environment and what is happening with the crop profile overall. But when we have plants that are just on the edge of being resistant to these diseases, we again see the greatest susceptibility right when we get to the fruit fill stage. So why is that, and why does that happen? This is a question that have been trying to understand better for some time. And in the process of trying to understand diseases at this stage of development, I learned a lot about plant hormones and how hormones and nutrients interact with each other to either increase or decrease disease susceptibility. So I wanted to speak to some of those pieces. The first piece, we believe that plant hormones are regulated by mineral nutrition. This is very important because today there is a much broader understanding of phytohormones. We're still learning a lot about these various compounds and how they drive plant growth. And increasingly, in many different, with many different horticultural crops, if we're working with cherry production, we might be working with gibberellic acid or with grape production. So growers are increasingly beginning to use different hormones to manage fruit size and fruit development and overall plant size and development with a variety of different horticultural crops. These are very valuable tools, but what we have observed time and again is that these phytohormones can actually be regulated by the nutritional balance inside the plant. And what that means is the effectiveness of any phytohormone applications that are applied can vary substantially based on the nutritional profile of the plant. So in other words, sometimes a hormone application, what might be considered a very low dose, a very low application, can produce a very substantial response. And the reason it produces such a substantial response is because it has the needed nutritional profile inside the plant to support that hormone expressing itself very strongly. Then on the other hand, occasionally growers will apply phytohormone products and they get a greatly reduced crop response. And the reason they get such a reduced response is because the plant is lacking the nutrients that have a synergistic effect and that are needed to support that specific hormone. So all of this, when we think about this, what this really means is that we can actually shape a plant's nutritional profile and as a result, shape a plant's hormonal profile as well and produce a very different overall response. The second very important piece is we believe that healthy plants are always root system dominant, or stated another way, they're always cytokine dominant. They always have more cytokines than they have auxins. And I want to unwrap a bit what this means and how we are observing this and what it is that we're looking for in the field. So one of my mentors used to say that roots are the brains of a plant. They are the neural network. And if we want to have a really healthy plant, we need to have a really healthy root system each and every day. The moment that the root system starts going into decline is the moment overall plant health starts to decline as well. And I've certainly observed that to be true, and I want to describe a little bit why that is happening and how that is happening and what's going on. The third piece, we believe that hormonal imbalances are a fundamental cause of disease susceptibility. Now, if we go back to the very first point that I made, we believe that hormones are regulated in the plant by nutritional levels. Then you may ask the question, well, if hormones are regulated by nutrition and hormonal imbalances are the cause of disease susceptibility, then aren't we really saying that nutritional imbalances are the foundational cause of disease susceptibility? And the answer is yes, in general. However, when we begin describing phytohormones, there are many cases where a very slight nutritional imbalance can have an unexpectedly large disease susceptibility response. And so much greater and much more so than, let's just say for the sake of discussion, that you're growing a crop that has a calcium deficiency, and you might think that the calcium deficiency is going to result in a crop that has calcium-related fruit disorders, blossom and rot, bitter pit, and so forth, and that's the problem. But in addition to that, in addition to the physiological fruit disorders, the calcium-related disorders, we also see very rapid shoot growth, very long internodes, very low carbon wood on tree fruit. So we see all of these other challenges where plants are vegetatively dominant, they don't have enough root system dominance, and that can also be attributed to the calcium deficiency. And it could be argued that in the long term, the poor vegetative growth, the poor quality vegetative growth, is actually going to have a bigger impact on overall crop health than just simply the calcium-related physiological disorders. So I'd like to give you a quick overview of the major plant hormones. So we have 5 major groups that are relatively well known and identified today. We still don't fully understand how all of these plant hormones interact with each other. We think we know a lot and we understand it reasonably well, but we're still constantly discovering new things. So in these 5 major groups, we have auxins, cytokinins, gibberellins, abscisic acid, and ethylene. So abscisic acid, ethylene, we may discuss briefly, but the emphasis, the core piece that I want to focus on tonight is the first 2 groups, auxins and cytokinins, because understanding how these 2 groups interact and play together really can shape how we manage our crops to such a degree that we can actually walk out into a field and visually evaluate which of these hormones is dominant and how susceptible our crop may be to diseases in the field. So let's first look at auxins. Auxins are produced in growing shoot tips, and it's missing from the slide here, but auxins are actually produced in 2 places. They are produced in the growing shoot tips, and they are also produced in the seeds. So they're produced in those 2 places. Auxins have an antagonistic relationship with cytokinins. The 2 of them compete with each other. They antagonize each other. When plants have high auxin concentrations, that produces apical dominance, which means that the vegetative part of the plant, the vegetative biomass and the new shoot growth, is going to absorb or going to receive most of the sugar flow that is produced during photosynthesis. So an additional characteristic of auxins is that auxins determine the sugar flow and which sugar sinks the plant moves sugars to following the photosynthesis process. So you have 3 major sugar sinks. You have the root system, you have the fruit, and you have the shoots. So auxins are produced in the fruit, in the seeds, and also in the shoots. So typically what happens is when we have a plant which is auxin dominant, we'll get very rapid shoot growth and rapid fruit fill as a result. So let's look at cytokinins for just a moment. Cytokinins are the other part of our pair here that we want to discuss tonight. Cytokinins are produced in growing root tips rather than in growing shoot tips. And cytokinins trigger reproduction. So when we have a cytokinin dominant plant, the cytokinins again have this antagonistic relationship with auxins. So when you have cytokinin dominance, you produce a plant that has very tight internodes, and it triggers strong reproductive bud set. So you have large numbers of reproductive buds. And cytokinins, so the interesting part here is that it says cytokinins are produced in growing root tips. That means they need to be growing every day, every 24 hours. The moment root growth stops or slows down, cytokinin production slows down. And so for this reason, we need to have root growth constantly happening. We need to have growing root tips every single day in order to maintain cytokinin dominance. So cytokinins are produced in these growing root tips, and they maintain root system dominance, and they move to the upper part of the plant, and they try to suppress the upper part of the plant's auxin dominance and try to keep internodes short and tight. So we have tight internode spacing. Then we have gibberellins. The simplest way to think of gibberellins is that they give us very rapid shoot elongation. So when we apply gibberellins to a crop, it's very common for us to see very large internode spacing, so very wide internodes. Gibberellins are in high concentrations in seedlings, so when a seed germinates, we get this extremely rapid stem elongation as the seedling emerges. That is a result of gibberellins' function inside the plant. And then, of course, we also have ethylene. Ethylene triggers senescence. So you can actually trigger early maturity on a crop by adding minerals such as boron, which increase carbohydrate transport into the fruit and triggers ethylene formation. Or you can also delay senescence on a crop and keep a crop in a vegetative state much longer by applying nutrients such as cobalt, which suppress ethylene formation in the seeds and in the overall plant structure. So, and then we have 9 other known phytohormones that we are still learning about. There's still a lot of information. There are a number of these which are very interesting. The jasminates, salicylic acid, the brasinosteroids, and at the bottom of the list we have triocontanol. So there are a number of compounds on this list which have some very interesting effects, particularly in the area of producing disease resistance and insect resistance that we hope to learn a lot more about in the next few years. So I'd like to focus on talking a little bit about auxins versus cytokinins. What happens inside the plant and how can we manage it? So as I mentioned, auxins are produced in growing shoot tips and in the seeds. So think about what this means. Let's say we have a tomato crop that is, it's a determinate tomato variety. They are growing very well. They're pollinating and setting the 5th to the 6th cluster. They are about 30 inches tall. And at this stage, the first cluster at the bottom of the plant is just beginning to fill fruit very quickly, which means that as we get, and so the first cluster might be on fresh market round tomatoes, might now be, let's say each fruit might weigh 4 to 6 ounces, be 2 to 3 inches in diameter. The second cluster will be slightly smaller than that. The third cluster will be smaller than that. So the bottom 3 clusters, we are already in the fruit fill period. So as we are in the fruit fill period, what this means is that the seeds are developing inside the fruit. And as the seeds are developing inside the fruit, they're producing high auxin concentrations. And the high auxin concentrations in the seed and in the fruit are attracting sugar to move into the fruit. So what happens at this stage is when you have a crop that is not producing enough photosynthates, it has a limited sugar supply because of the tremendous, now at this point, so let me back up just a step. Through the vegetative stage, through vegetative development, you have auxin production in the new shoots, and you have cytokine production in the growing root tips. So you have these two that are relatively balanced. Now you get to the fruit fill period and seed development, and all of a sudden the auxin production in the seed. So now you have auxin production in the seed and you have auxin production in the growing shoots. It becomes very easy for this plant at this stage to become auxin dominant. And because what has happened, the reason it becomes auxin dominant is the majority of the sugars are flowing to the fruit and to the new shoots. And such a small volume of sugars goes down to the root system that we get reduced growth of the growing root tips. So every 24 hours, every 24-hour photo period, we get less root growth. And as a result of having less root growth, that means we have less cytokine production, which now gives us auxin dominance. So this is a problem. And this is why the foundational reason why we have this disease susceptibility happening when we get to fruit fill. So let's look at a tomato crop. These are pictures of the exact same tomato crop about 10 days apart. On the image, the picture on the left, you can see a tomato crop that is, the entire canopy is very dense. It's very flat across the top. It looks like somebody took a hedging shears and turned this tomato crop into a hedge. So the canopy is really tight, which means that we have very tight internodes. We don't have very rapid shoot growth. And that is an expression of a plant that has cytokine dominance. It has root system dominance. So what this means is that every 24 hours, there are more growing root tips than there are growing shoot tips. That's essentially what we're talking about. And the reason we have more growing root tips is because a larger volume of sugar is moving down to the root system to drive root growth. If we look at the plant on the right, this is the exact same crop 10 days later. And the difference in this 10 days has been that we've gotten to the fruit fill period, and the plant was producing a limited volume of sugar because of cloudy, overcast weather, and there wasn't enough sugar to both fill fruit and to feed the root system. So the plant, of course, the genetic tendency, the desire is to reproduce. So the plant channeled all the sugars and all the energy into the fruit at the expense of the root system. So the root system started going into decline. And as the root system went into decline, we get this very rapid shoot growth out of the top of the plant, where previously what was this really tight hedge, this really tight canopy, now we have auxin dominance and apical dominance. And right at this moment, we have severe disease susceptibility. This is when early blight happens. This is when bacterial speck and bacterial spot and septoria leaf spot and all of these various pathogens that affect the leaf surface, this is when we get the greatest degree of disease susceptibility. These diseases can occur earlier in the season, and they sometimes do. But the moment of greatest plant weakness is at this moment because we have lost root system dominance. So the longer we can keep root system dominance, and it's possible to keep the root system dominant throughout the entire growing season. Growers often ask me this question. The question is, well, we've had these environmental challenges. We had cloudy, wet weather. We weren't able to put on a nutrient application. and we've lost root system dominance. We have this very rapid shoot growth coming out of the top of the plant. What can we do to reverse that and to shift it back to root dominance? Reversing this and shifting back to root dominance is very, very difficult. I've only seen it being accomplished successfully on a few dozen occasions, a very small percentage. It's relatively easy to prevent. It's very difficult to reverse. So it's very important to try to prevent this shift from happening in the first place, if at all possible. So the next question becomes, how do we do that? How do you manage, how do you work to prevent the shift? So historically in the agriculture space and horticulture space, products that have been used to manage auxin dominance and try to prevent auxin dominance are seaweed applications and synthetic cytokinins. So there are a number of synthetic cytokinin products available in the marketplace today, and in many cases growers are applying these products in an effort to maintain, to trigger strong reproduction, to trigger bud set, increased number of flowers, fruits, pods, clusters, whatever the case might be. And they're very useful. They're very useful tools. But the challenge that we have observed is that in many cases they are inconsistent. They produce inconsistent results because of inconsistent nutritional profiles inside the plant. So if we put on a cytokinin application on a plant that has a low calcium availability, we're going to get a very small response, a very limited response. But if we put the exact same application rate on the exact same crop at the exact same stage of growth on a plant that has an adequate or generous supply of calcium and cobalt and other trace minerals that have a synergistic effect, we're going to get this a tremendous crop response that will be 3 to 5 times bigger than the crop that had poor nutritional profile. So what we have developed, our approach to managing these hormones and these hormone applications is to develop what we refer to as synergistic stacks. So we work with the hormone itself, but then we combine it with synergistic nutrients so that we can have a compounded effect. So for this specific challenge, this specific cytokine and auxin imbalance that I'm describing, that I'm talking about, we use a stack that begins with a high cytokinin seaweed. That's kind of the foundational material. And then we add these various minerals. We add calcium and cobalt, molybdenum and manganese. And very importantly, we want to make sure as well that the plant has a healthy population of PGPRs, plant growth promoting rhizobacteria, in the root system, because these PGPRs they actually synthesize cytokinins and feed the plant cytokinins in the root system. So these bacteria, these specific groups and strains of bacteria in the root system, are a very important part of an integrated approach to maintaining high cytokinin production and preventing auxin dominance. So on many of these crops that have this challenge with these reproductive crops, we will apply PGPRs to the root system multiple times during the growing season, just re-inoculate them and reinvigorate them to make certain that we have high cytokinin production in the root system itself. And then the last piece and the final piece is adding and using Accelerate. So when we talk about developing these synergistic stacks, I've just given you the formula for some of the materials that we've put together and the approach that we take. And this is kind of our recipe for success that we've used. And then we've tried to, just for ease of use for the many customers that we work with, we've packaged this formula together into a single product called Accelerate. So Accelerate was designed specifically to spike cytokinin concentrations in the plant and to drive to increase reproduction. So we've had exceptional successes at increasing the number of flowers or reproductive buds per plant. So on beans and soybeans, for example, we've found that it's relatively straightforward to increase the pod count and the blossom set by as much as 80%. So we can produce these tremendous crop responses by having this cytokine dominance. But what has been really intriguing for us is that not only can we produce these strong reproductive effects, but we can also produce a very strong disease suppressive effect for the very reasons that I've been talking about. So a couple of brief examples. This is Downy Mildew on basil, and the image on the left was before application. It's not super clear on this photo, but you can see some of the light pale yellow sections on the leaf, and that is where we have a downy mildew infection on the bottom side of the leaf. 5 days after a foliar application of Accelerate, the downy mildew completely disappeared, which is almost unheard of. It's very difficult, a very difficult disease to manage for basil production. So we actually got this tremendous disease resistance response from a product that was designed to shift and to manage a plant's hormonal levels. And of course, you can also see the leaves are much darker green. The plant is looking a lot better overall. There's some more data and some more information from this farm, but their overall basil harvest and yield increased by a factor of about 6 times where they before and after the product application. And then there was another experience that we had on dryland corn in southwest Kansas, where the crop was infected with spider mites. We put on, in this case, Accelerate was actually applied through the overhead pivot, through the pivot irrigation at a rate of about 2 gallons per acre. And it takes about 48 hours for the pivot to make an entire circle. We found that 48 hours after the Accelerate application, the spider mites were dead. So this was an unexpected, we didn't expect this. Actually, we didn't even know the spider mites were present when we made the recommendation for the Accelerate application. They had just started moving in. So we made a recommendation for the Accelerate application just based on what was happening with the plant and the stage of development. And by the time the product arrived and the grower applied it, we had the spider mite infestation, and then it disappeared. So that was a lot of fun. First question, Chris Pelzer asked the question, is there a real risk of bringing plants out of balance by applying too much hormones in the form of seaweed? Can you apply it as a standard treatment no matter what? So this is a great question, and I've asked this question as well. The brief answer is that I have yet to observe ever having a crop that had an excess of cytokine. It may be possible somewhere, somehow, but I have never seen it. And the only possible downside that I could potentially see would be if we had a vegetative crop that was getting a limited amount of vegetative biomass and vegetative growth because of the strong cytokine dominance. So let's say you were producing lettuce or kale or spinach or some type of salad greens, then in those situations, I can see where there would be a possibility if you applied extremely high amounts of cytokinins, and I would anticipate it would be in the order of 10 times the recommended application rates. I can see where theoretically it would be possible to get to a point where you constrain plant growth and you have limited plant development. I have never observed that to happen, but I would expect that it would be possible. And then Chris, you asked a second question as well. Do I know of the relationship between SAR, ISR responses and cytokine dominance? So Um, I'm not aware of any direct correlation that has been studied and that has been documented. However, from a practical experiential perspective, what I can say from experience is that the crops that have cytokine and dominance that have a large root system are also the exact same crops which have a very rapid, very strong SAR or ISR response. So for those of you who aren't familiar with that terminology, SAR stands for systemic acquired resistance and induced systemic resistance. So what I do know from experience is that the plants who have larger, more vigorous root systems have a much stronger immune response, and they're much more disease resistant as a result. Great questions, Chris. Thank you for asking those. Rika Henderson asks the question, what are PGPRs? So yeah, I flew over that pretty quickly. PGPRs is the acronym for this group of bacteria in the rhizosphere that are called plant growth promoting rhizobacteria. So plant growth promoting rhizobacteria are bacteria that they serve a number of different functions. One is that they trigger an immune reaction in the plant. They trigger a SAR response. But very importantly is that they actually synthesize these various plant hormones, particularly cytokinins. So they actually synthesize cytokinins and transfer cytokinins into the root system and trigger cytokine and maintain cytokinin dominance, which is why they're called plant growth promoters. So they are plant growth promoting rhizobacteria, a very, very influential and very important group of bacteria that we inoculate on our crops all the time. Anthony asks the question, is the Accelerate product helpful for control of powdery mildew on grapes and mangoes? And how often should a foliar treatment be applied? So we actually have used Accelerate. We don't have a lot of experience on mangoes, so I can't speak directly to that, but we have used Accelerate. There are many crops that are susceptible to powdery mildew, ranging from cherries and spinach and salad greens and cucumber crops, etc. And of course, the fungal organism that causes powdery mildew is not exactly the same on all these various species. However, we have found that the nutritional profiles and the hormone profiles of plants that are susceptible to powdery mildew are almost identical, irregardless of species. So we have used Accelerate to manage the hormone levels and to manage reproduction, and have actually found a very nice response to both downy mildew and powdery mildew pressure very consistently. We are typically applying Accelerate at a rate of about 6 to 8 quarts per acre. And we have seen these side effects, these benefits of increased disease resistance on a broad variety of crops. So I would expect that Accelerate would give you a very nice beneficial effect on both grapes and mangoes. Great question, Anthony. Thanks for that. Jonathan Correa, when are the best times to make applications of a product like Accelerate? Is there a protocol to follow from seeding or transplant and throughout a crop's life? This is an awesome question, Jonathan. So yes, there are specific windows at various stages of a plant's development that we call critical points of influence. And these critical points of influence are, they're usually very narrow windows that determine a great deal of that plant's future reproductive potential. And so we have another webinar coming up where I will be going into more detail on these critical points of influence and how to manage them specifically. But just very briefly in general, there are the critical points of influence are associated with the periods when a plant is determining its future reproduction. And so there are 4 periods. The first period is when reproductive buds are being initiated. And that's different for every crop. So I can't speak specifically to a broad list of different crops, but the first period is reproductive bud initiation. The second period is blossoming and pollination. The third period is cell division, which is the 10-day period after blossoming and pollination. And the fourth stage is cell expansion, fruit fill. So each of those 4 stages, each of those, any one of those windows is when you will get the greatest economic crop response from an accelerate application or from any product application that supports the plant's hormonal development and integrity and nutritional integrity. It's a great question. Daniel Picasso asked the question, have you observed a pattern of vegetative and reproductive growth with ammonium and nitrate nutrition? This is another excellent question, Daniel, and the answer is yes, we have. We find that when plants have high levels of ammonium in the plant sap, or when they are absorbing a lot of ammonium from the soil profile, they tend to want to reproduce. And this is also associated with high temperatures, high heat conditions. So if you have high temperatures, then you get high levels of ammonium production in the leaf and in the soil profile. So typically, when we have higher ammonium levels, we see very strong reproduction. And then we see nitrate, nitrogen, associated with very strong vegetative growth. With that being said, the healthiest crops, those that are being managed the best, that are producing the greatest crop response and highest yield and best quality and greatest disease and insect resistance, are crops which are absorbing the majority of their total nitrogen in the form of amino acids and microbial metabolites. So amino acids and urea and so forth. So our goal is to have on sap analysis, we want to see a plant that has a generous supply of total nitrogen. The total nitrogen in the plant sap is a very generous number. And we have nitrate levels and ammonium levels at 0. So none detectable on nitrates and none detectable on ammonium. So those really are the healthiest plants. And when that happens, this entire conversation about reproductive versus vegetative growth from these different minerals kind of goes out the window. And also something that I would like to mention is that when we talk about cytokine versus auxin dominance and these various nutritional profiles, we can have this conversation and it can sound really complicated, but in reality it's not. It's actually very simple because the beauty is that it was designed to work. And we have found over and over again that we can, if we give plants the needed nutritional profile, then the hormone balancing to a large degree takes care of itself. It flows very well the way that it was intended to flow. Tom Furman asks the question, you mentioned the synergistic stacking effect, specifically with calcium and boron. Are there any specific nutrients to avoid that would have a negative effect in the auxin cytokine balance? So I'm assuming, Tom, that when you ask this question, what you're referring to as a negative effect would be the negative effect of auxin dominance and inadequate cytokinins, which would be true for most crops. And by the way, I've been sharing this information with the assumption under the premise that when we talk about cytokine and auxin dominance, it's true for all crops, but this is primarily and most importantly true for reproductive crops. So if you have a vegetative crop like salad greens and so forth, then this becomes less of an issue because you don't have auxin production happening from the seeds. So you don't actually have seed production, and so it's a lot easier to maintain cytokine and auxin balance. So anyway, to come back to your question, are there specific nutrients to avoid that would have a negative effect that would produce auxin dominance? So there are two nutrients that will drive auxin dominance. Actually, there are three that will drive auxin dominance. And those would be nitrate, nitrogen, chloride, and potassium. So I just spoke of nitrate a moment ago. We want to limit nitrate absorption by a really healthy crop if we can. And the same holds true of chlorides. Plants need a limited amount of chloride, but an excess will drive auxin development. And the same is true of potassium. So again, of course, crops need potassium, but when you have excessive potassium, it's going to drive auxin dominance. Jonathan asked the question, is Accelerate better used as a foliar spray or as a soil drench? So Accelerate was really designed to be used as a foliar spray, and that's where you're going to get the greatest crop response, because when we're talking about these hormonal imbalances that are happening, they're happening throughout the entire plant, of course, but in order to shift them, we typically need a very rapid snap response. We need a strong trigger, and we don't get that strong trigger effect to nearly the same degree when we apply a product to the soil, because there's this gradual absorption by the root system, whereas if we apply it to the foliage, we get this very rapid, almost immediate crop response, and that's where we get the greatest effect. So Jonathan also asked the question, would Accelerate be good to use for most transplants to improve the plant's ability to get established and to encourage strong root growth? The answer is overwhelmingly yes. Accelerate can be very powerful to use in transplants for a couple of different reasons. One is the obvious one, it drives cytokine production, which means that it'll drive very vigorous and very aggressive root systems. So that's awesome. That's one of the things that we're looking for. But in addition to that, for many of our annual vegetable crops, which I'm assuming is what you would be transplanting, the bud initiation stage happens very early in the plant's life, much earlier than most people ever anticipate. So if you take cucurbit crops, for example, let's say cantaloupe or watermelon. For cantaloupe, our goal, a really healthy plant, we want to pollinate and harvest what are termed the crown blossoms. So there are usually 3 to 4 female blossoms that are there the first female blossom on each of the individual lines that eventually comes off the main crown. And what this means is that if you have a really healthy plant, a really healthy crop, and you're able to successfully pollinate and harvest the crown blossoms, all of the melons will be within 18 inches of the crown. So you can have all the melons right on a plastic line, right down to the field for cantaloupe. But the interest, most growers don't set and harvest the crown blossom. They lose them because that bud initiation for those female buds actually happens between first and second true leaf. Well, in most cases, for a cantaloupe crop, the first true leaf happens when the seedling is still in the greenhouse. And the stage between first and second true leaf, that's when they generally get transplanted and have a whole lot of transplant shock. So when we use Accelerate as a transplant aid and a biostimulant, then we're able to have very strong cytokine dominance and trigger strong reproductive buds, and we can actually keep those crown blossoms, which is a really big deal. So that is true. I just gave you an example of cantaloupe, but that's true of tomatoes and a broad variety of annual vegetable crops, is that we get the biggest response when we apply these products very early during the bud initiation stage. Anthony asked a question, a bit off topic. It seems that mono and dipotassium salts, mono and dipotassium phosphates, have been used as a systemic fungicide and a possible immune stimulant? What are the pros and cons of using this agent? So mono and dipotassium phosphates are interesting materials. They give plants a strong energy shot, and we often get a very nice phosphorus response from them. I'm not aware of any substantial downsides in that they don't really have any negative effect on the plant or on the microbes that are living on the leaf surface that I'm aware of. So in general, I think it's a favorable material to use. It's obviously a very, very potent material and needs to be used carefully, but they're excellent ingredients to be using. Daniel asked the question, do we make use of nitrification inhibitors to add reproductive potential for ammonium-loving crops? And this is a great question, Daniel. We sometimes do on farms that we're working with that are in transition, but only on a very limited basis. Our goal is to have the crop absorb the great majority of its nitrogen in the form of microbial metabolites, in the form of amino acid nitrogen. So the way that we accomplish that is by making sure we have tremendous, very vigorous bacterial communities in the root system. And we constantly feed them. We're feeding them sugars from root exudates. We're giving them biostimulants in the irrigation system. We are combining any nitrogen products that actually get applied. If we have a need for applied nitrogen, we are combining that with sulfur. We're combining it with humic substances. We're perhaps combining it with rejuvenate. And so our entire process is making sure we want the plant to absorb all of its nitrogen in the form of urea or amino acids. So when that happens, that's when we get the greatest plant health. And so we actually get the greatest response from having very aggressive bacterial systems rather than trying to suppress certain segments of that bacterial system with the nitrification inhibitors. Anthony asks the question, Anthony Granatelli, the directions on Accelerate imply that it should only be used once just before flowering. Could multiple applications improve results? So yes, multiple applications can improve results. And we put those instructions together when we were first developing that product and testing it in the field. When you are working with a crop that blossoms and pollinates for an extended period of time, let's say tomatoes, for example, we have the tomato growers that we work with, large-scale tomato growers, are usually applying Accelerate once every 10 to 14 days for a total of maybe 4 to 5 applications during the reproductive period. And so they apply it continuously for an extended period of time. Now, if you are thinking about, let's say, tree fruit or corn, let's say corn, for example, or small grains, where you have all the blossoming and pollination happening in a very narrow window, and it all happens in a matter of a week or two. For many of those crops, we're only doing a single application. But for the multiple fruiting crops that blossom and pollinate over an extended period of time, we will, in many cases, apply multiple applications throughout the season. Tom Furman asked the question, do we notice the same type of benefit from cytokine management and Accelerate in crops with a single fruit set, such as corn or stone fruit or hops, versus indeterminate crops like tomatoes? So the answer is yes, we do. The results have the potential to be greater with the multiple fruiting crops, but we also see very substantial results with the single fruiting crops. So if you think of stone fruit, for example, or apples, well, the interesting part so we have to come back and ask the question is, how do you make money with a specific crop? And this is actually a question that we put a lot of thought into. So on stone fruit, for example, You don't make money by increasing the number of fruit per tree. You're already thinning and reducing the number of fruit per tree that you keep. The way you make money on stone fruit is by increasing fruit size. So in terms of economic response, you're not going to get the same degree of economic response from Accelerate on stone fruit. But if you're dealing with hops, for example, the way you make money with hops is the number of blossoms that you have per plant. So in that case, with hops, you can produce a very strong economic impact with Accelerate. And in those crops, in a crop such as hops, we would recommend a strong Accelerate application to get the greatest number of buds possible. Mark Valling asked the question, it seems most of the questions and answers are for fruit and vegetable production. What kind of advice do you have for corn, beans, and wheat? So I'm using a lot of fruit and vegetable examples because those are plants that I'm very familiar with and study very deeply. But the reality is it's exactly the same for all plants. So you can, in terms of thinking about hormone balance, you can group all crops into essentially three groups. You have what you could think of as the single fruiting crops, where you have all the blossoming and all the pollination happening in a very condensed time window. So this would be tree fruit, such as apples and pears, but it's also corn, it's also small grains. You have all the blossoming and pollination happening in a matter of days or weeks. And so for all of those crops, you will have the greatest, generally, again, you have to ask the question, how do you make money with this crop? And if you can make money with wheat, for example, or with corn, you can make money by increasing the number of kernels per ear and the number of rows, for example, which is something that Accelerate can impact. So you want to put on an Accelerate application at the stage development when you have ear determination, embryo determination, which for a corn crop is about 42 to 49 days after germination. So the same also holds true for soybeans, actually. We've gotten incredible responses from soybeans, and typically we're putting on an Accelerate application on beans at about third trifoliate, and I would say 80, actually probably 90+% of the time, we get anywhere from a 50 to an 80% increase in pod count. So soybeans respond very strongly because they are one of the second group of plants, which is what I think of as the multiple fruiting crops. So the multiple fruiting crops are the crops that blossom and pollinate over an extended period of time: soybeans, tomatoes, etc. And then the third group of crops would be the vegetative crops, which we're not harvesting the fruit from. So vegetative crops are alfalfa and pasture and kale and spinach and salad greens, etc. Jonathan asked the question, would you use a product like Accelerate with other foliar applications like Photomag for increasing a plant's photosynthetic capacity, or in conjunction with biostimulants? The answer is yes and yes. If and when it makes sense and when it's needed. So we often combine Accelerate. Accelerate is very powerful just on its own as a standalone, because it is already, it's designed as one of those synergistic stacks. But in addition to that, we have many growers that also add Accelerate to a foliar mix that they might add another 3 or 4 products to get the greatest crop response. So those products can be nutritional products, other biostimulants, microbial inoculants such as Micro 5000. They'll use a number of different things to get the greatest crop response. All right, well, I will take one more question and then we'll wrap up. Anthony asked the question, if you have young fruit trees and you wish to have the tree grow and size up as fast as possible, instead of spending energy on reproduction the first few years, what strategy would you follow? Oh, Anthony, this is an awesome question. I don't know if I can give only a short answer to that question. So very briefly, the strategy that I would follow is, I'm assuming, I'm assuming for the sake of discussion that you are probably grafting onto a rootstock. You have a different cultivar and rootstock. So we've actually done some experimentation with a few growers that we've worked with on this with some exceptional results. So the strategy that I would follow would be to plant the rootstock in place and give it an ideal environment. Irrigate it, foliar feed it, fertigate it, give it an optimal environment, and try to keep that rootstock plant intensely cytokine dominant and grow a huge root system. Grow the largest root system you possibly can on that rootstock. Then, in place, you graft in place onto that rootstock. And again, of course, how you do this is there's lots of questions depending on what tree crop you're talking about and so forth. But then you graft in place. And now what that means, when you graft in place, you have a scion and you have only a relatively small amount of Auxin production, but you have this huge root system that has a tremendous amount of cytokine production. And the result will be that you can get a tremendous amount of growth of vegetative biomass, but still be extremely high quality. So you can grow in a single year from a scion bud, you can grow as much as anywhere from 7 to 10 feet of vertical vegetative growth that has internode spacing of 1.5 inches to a couple inches apart, very tight internodes, very tight branches. That is very high quality, high carbon wood, because you have this huge cytokine reserve and reservoir by having this large root system and having this completely disproportionate ratio between cytokine production in the roots and Auxin production from the bud. So that would be the ideal. And then of course you could partner when we talk about growing huge root systems with the rootstock seedling, then that is where we use Accelerate and cytokines and all these various different tools, the Pg Prs and so forth. It's an awesome question though, and something that I love, pretty pumped about. I'll take one more question. Judy Johnson asked the question: in a rubus nursery setting where roots are the commercial product and we want to discourage flowering or fruit sap, does Accelerate have a use? So I would say yes, it does. But you are using it in this case, you're not using it. Again, remember the purpose of Accelerate is to maintain cytokine dominance. So the way that we've been talking about it, the way that I've been describing it, has been maintaining a cytokine dominance in association with a plant that is reproducing. And so for the situation that you're describing, you're not actually producing a crop that is reproducing, at least you want to avoid reproduction. So in this case, you would put on an application of Accelerate, but out of sync, out of phase with the reproductive cycle. So rather than timing an Accelerate application at the moment of bud initiation, you would actually put it on earlier than that so that you trigger more, so that most of the cytokines go into the root system rather than triggering stronger reproduction.